see that.
What kind of mill do you use?
I think we use a two roller mill over there.
Yeah.
For a lot of Scotch distilleries, they'll use a four roller.
Okay.
And there are one or two places that actually use a hammer, and they'll use a mash filter. But those are mainly what's called grain whiskey distilleries.
Okay.
So
Derek, did you just put it through once or twice?
we put it through twice for this.
So it's kind of like a flow.
Sure. Sure, yeah, we're simulating a four roller mill. Alright. I'm going to go ahead and start adding this in.
So are you trying to pitch this at the same temperature you're going to mash it, or are you pitching a bit hotter?
A bit hotter because we wanted to get to about 145 degrees or 63 Celsius.
Right. So you're doing a step?
No, it's a single infusion.
Single infusion.
Okay.
And that's normal for Scotch making.
So we just calculated what your strike temperature is going to be
Right.
based on your grist to water ratio.
How do you figure out the ratio?
Well, it has some influence on like body in a beer. So there's ideal ratios for extraction. Then there's just literature about it. We went a little bit higher. We're fermenting the entire mash, and so we just want to be able to extract as much as we can when it's done. So we need more liquid without having to add water later.
Yep.
An excess of water here will give us. It'll just make all the reactions occur more easily.
What's the ratio you put?
We did was it 4 liters to every kilogram, roughly.
So it's about 33% total by the total weight. I calculated what you told me, which was a pound to a quart. A pound to 2 quarts.
So you're using 41 liters.
Okay, I'll work that out later. So
So what's our total volume moving here?
We need 41 liters. 20?
So what all's going on in the cooler now? The hotter.
Okay, so what we've got going on is you have starch granules starting to swell. And with that, you have amylose starting to come free of those starch granules.
Right.
So as they swell, essentially begin to break apart, right? And you've got amylopectin coming apart. As that happens, you have enzymatic activity coming from the barley. You've got alpha amylase, which is an endoenzyme, and it begins to chew up these starch molecules. You also have beta amylase, which is an exoenzyme, and it's nibbling at the enzyme, essentially, right?
Right. So the endoenzyme's breaking down the molecular weight, which is actually the enzyme of liquefaction. So it's breaking, so it liquefies the material. The exoenzyme is the saccharification. So it's starting to produce the maltose. And we'll go through this in a little bit more theoretical detail after we've actually, next week we've seen the process.
So there's another enzyme that's not quite at work yet, limit dextranase. And from what I can tell from my reading, is it'll actually really kick in early fermentation.
Yeah.
And it doesn't get denatured because we don't do a boil with Scotch making.
Yeah, that was one of my first revelations was no boil, so that when the fermentation's going on, there's still any residual starch degradation that needs to happen, can happen.
So it's putting it on the alpha 1-6?
Yeah, yeah, the limit dextranase. If you were making fuel ethanol, you would buy polyulinase, which is a similar action mode.
Okay.
Yeah, why is that enzyme active? Why is it not active during the normal batch?
It's a good question.
Most of it's because things aren't broken down enough yet. So it needs it needs to be fairly short branch, like ends near the branch points, otherwise it can't act. And so we can actually go into the details of that. It's because it's quite important if you want to get that every last fermentable glucose out of
62.
out of it.
62 is okay.
Oh, right. 66. Why don't
So this is for distillation, and particularly if you're doing this is a single malt because it's an all malt mash. But if you were doing a grain distillation, ethanol is your product, and the most so it's quite different. You don't want to leave any residual dextrins in there that might in beer they're going to provide body. And
yeah, but I mean like fluid light.